Hello and welcome to this video on solving radical equations. So all of these examples are going to have some kind of square root or cube root or something along those lines in the equation. So we're going to look at the different ways we can solve those. So the first example we have is the square root of 7x minus 3 is equal to 5. All right, our first step anytime we have a radical is we want to isolate that radical, whether it's in the form of the square root like this one is or whether it's in an exponential form. We always want to isolate it and then do the opposite. In this case, this one doesn't have an index, so this is a square root. So the opposite of taking the square root is squaring. What we do to one side, we have to do to the other. So when we square this, the square root squared, those are going to cancel out and we will be left with just what's underneath that radical, in this case 7x minus 3. On the right hand side, 5 squared is equal to 25. And now this becomes a linear equation. We want to solve that. So we can add 3 to both sides and we get 7x equals 28. Divide by 7 and we get x equals 4. Now anytime you're dealing with a radical, we're squaring it. So we could potentially introduce a negative answer. And so we always want to check to make sure that the answer we get works in the domain of the original function. So if we check it, remember always check in the original. So we're going to plug our x back in. So we're going to get square root of 7 times 4 minus 3. And our question is that equal to 5? So 7 times 4 is 28, minus 3 is 25, and the square root of 25 is equal to 5. So x equal 4 is our solution. All right, now let's take a look at the equation 7 plus the square root of 2x plus 1 equals x. We want to isolate that square root, so we need to move that 7 out of our way. So we're going to subtract 7 from both sides. And I'm not sure why, but I see a lot of students that just kind of ignore that x on the other side and just write the negative 7. We do have to include that x and solve x. We'll have x minus 7 on the right-hand side. All right, now we've got that square root isolated. We can square both sides, just like we did on the previous one. When we square the square root, they're going to negate each other, and we will only be left with what's inside, in this case 2x plus 1. On the right-hand side, we have a binomial squared. Remember, a binomial squared means that we have to multiply it by itself. You can either use the shortcut formula if you know it, or you can multiply x minus 7 by x minus 7, and you will get x squared minus 14x plus 49. And then now what we have is a quadratic equation. So we'll use all of the rules that, or any of the rules that will apply to this quadratic equation. Remember, factoring typically will be the fastest if it works. If not, completing the square and quadratic formula will always work. I like to have my x squared term positive, so I'm going to move everything to the right-hand side by subtracting 2x and subtracting 1 from both sides. That's going to give me 0 on the left. On the right, we've got x squared. Negative 14x minus 2x is going to simplify to negative 16x. And then 49 minus 1 gives us 48. And this one does factor. The factors of 48 that add to negative 16 are x minus 12 and x minus 4. Setting each of those equal to 0, we're going to get x is equal to 12 or x is equal to 4. Now again, anytime you have a square root in your original, you do need to check. Anytime you have a square root, fourth root, sixth root, anytime you have an even root, you could introduce extraneous solutions, extra solutions. So we want to check this, and we always check by plugging into the original, so make sure that you're plugging back into that original equation. So 7 plus the square root of 2 times 12 plus 1, we want to see if that's equal to 12. 2 times 12 is 24, plus 1 gives us 25 underneath that square root. Square root of 25 is equal to 5, plus 7 is equal to 12. If we do the same thing for 4, underneath that square root, we're going to get 2 times 4, which is 8, plus 1 is 9. The square root of 9 is 3. 7 plus 3 is not equal to 4. And so that is an extra solution. So x equal 12 is our only solution to this equation. All right, our next one is written in an exponential format. Here we have the quantity 4x minus 4, all raised to the 1/3 power. It doesn't matter whether it's in this exponential format or whether it's written as a cube root. In this case, the number in the denominator tells you what kind of root it is. This one's going to be a cube root because we have a 3 in the denominator. We have that quantity equal to -4. Our approach is the same. Even though this is not a square root, this one's a cube root, we're going to do the opposite. In this case, 1/3, we're going to raise it to the 3/1, or cube both sides. And when we do that, our 1/3 and our third are going to, we have a power raised to a power, so we'll multiply those exponents and we will get just 4x minus 4 to the first. On the right hand side, we have the quantity -4 cubed, which simplifies to -64. We can add 4 to both sides and we get -60. Divide both sides by 4 and we get x is equal to -15. Since this is a cube root, cube roots don't introduce extraneous solutions because the plus or minus is going to stay the same. But it's always a good habit to get into to check your answer. And so let's go ahead and we'll keep with the theme of this one and check your answer. So when we check, remember, always plug back into the original. 4 times -15 minus 4, quantity to the 1/3, equals -4. Inside the parentheses here on the left-hand side, we're going to get -60 minus 4 is a -64. And -64 to the 1/3 is equal to 4. And so our answer does work out. All right, this last example is a little intimidating at first, but we're going to just approach it in the exact same way. Here we have the square root of 7x plus 1 minus the square root of x minus 5 equals 6. So here we have two square roots. We want to isolate one of them. It doesn't matter which one you isolate first. Because of signs, I'm going to go ahead and add the second one to the other side to just save a little bit of steps. It's a little bit easier to isolate the 7x plus 1 underneath the square root. And then approach it the same way that we did our first two examples. We want to square both sides. On the left, squaring the square root is going to give us 7x plus 1. On the right-hand side, we do need to multiply this out. Just like we did on that second example, we have to multiply this out. And so we get 6 plus the square root of x minus 5 times 6 plus the square root of x minus 5. If we square something, we multiply it by itself. So if we multiply this out, FOIL this out, we're going to get 6 times 6 is 36. 6 times the square root is going to be 6 times the square root. Our inside is going to be the square root times 6, so we get 6 times the square root. And then last times last, we have the square root times itself. Well, that's just the square root squared, which is going to leave us, just like we saw on the left-hand side of this equation, with what's underneath that square root. And I did put parentheses around that. The parentheses aren't doing anything at all. In fact, I'm going to drop them on our next step. I'm going to go ahead and clean up that right-hand side. We've got an x. We've got 36 minus 5 is going to be 31. And then 6 times the square root of x minus 5 plus 6 times the square root of x minus 5 is 12 times the square root of x minus 5. Okay, now this is in a similar situation of where we started our first two examples. We've got one square root. We need to get it by itself, completely isolate it. So let's move the other numbers to the other side. So we're going to subtract x. So 7x minus x is going to give us 6x. And then 1 minus 31 is going to be negative 30. And you could square it at this point, but the numbers are going to be rather large. So I'm going to go ahead and divide everything by 12 and completely isolate that square root. So 6 divided by 12 is going to be 1/2 times that x. And then 30 divided by 12, that's going to give us a GCF of, let's see, our GCF there's 6. And so we'll get a minus 5 over 2. Now we've isolated it, we can square both sides. When we square it, remember, multiply it by itself. So 1/2 x times 1/2 x is going to give us 1/4 x squared. 1/2 x times negative 5/2. We're going to get 2 of them just like we did on this step up here at the top of the screen. And so the formula that we use, if we have a plus b squared, it's a squared plus 2ab plus b squared, where here our a is the 1/2 x, so we square that, and then 2 times a times b, so 2 times 1/2 times x is going to be x, times negative 5/2 is going to be negative 5/2 x, and then square the last one, and negative 5 squared is 25, and 2 squared is 4, so we get 25 over 4. On the right hand side we have x minus 5, and we do have those fractions there. I don't really like fractions, especially if I want to try to factor this, so I'm actually going to get rid of those fractions. Remember, anytime you have an equation with fractions, you can multiply everything by the LCD. In this case, our LCD is 4. When we distribute that to our first term, 4 times 1/4 x squared is going to be x squared. 4 times negative 5/2 x is negative 10x. 4 times 25/4 is 25. What we do to one side, we have to do the other side. And so we'll get a 4 times x and 4 times negative 5. Now these numbers look a little bit better. So this is a quadratic, move everything to one side. We'll get x squared minus 14x plus 45. And the factors of 45 that add to negative 14 are going to be negative 9 and negative 5. So we do get two solutions here, or two potential solutions, because we do need to check those, x equal 9 and x equal 5. We do want to check those in our original, so we're going to be plugging into our original here. And when we plug that in, we've got the square root of 7 times 9 plus 1 minus the square root of 9 minus 5. We want to know, is that equal to 6? 7 times 9 is 63 plus 1 is 64. The square root of 64 is 8. 9 minus 5 gives us 4 in the second square root. Square root of that is equal to 2. And 8 minus 2 is equal to 6. So that one works. And then checking the other one, 7 times 5 plus 1 minus 5 minus 5, is that equal to 6? 7 times 5 is 35, plus 1 is 36. The square root of 36 is equal to 6. And then we get 5 minus 5 is 0, and the square root of that is still 0. And 6 minus 0 is equal to 6. So both of these are part of our solution set. All right, hopefully that'll help you guys out, and I will see you guys next time.